All right, we're going to go ahead and start talking about apportionment. And apportionment is kind of a simple idea. It's how do we divide out fairly a number of seats or a number of workers for a specific job based off of how much work is actually there. We do this in the House of Representatives with a number of seats that go to each one of the states in the country. And we do that based off of population, but we can do that for multiple things. Like, for example, how many patients, how do we hand out nurses to a hospital just based off of the number of patients they have on the floor. So this is a good distribution method that you can use for determining how many workers that you need on in a workforce situation. So here's a basic idea. Ms. Phillips has 50 identical pieces of chocolate which she is planning to divide among her 5 children. She wants to do this fairly because she knows not all 5 children are going to earn 10 pieces of candy apiece. So what she does is she decides to base it off of how many minutes they've actually worked. So the first thing I'm going to go ahead and identify is in this lesson we'll talk about seats, states, and population, okay? And so seats are what you're going to hand out. So in this case, we're going to be handing out 50 pieces of chocolate. Those are what are going to be distributed. Those are our seats, okay? The states are who get those number of seats. So the 5 children, those would be our states, okay? And then the population is going to be what we're basing this off of, the proportional mean. So our population is going to be our minutes. So we're basing this off of the population of minutes. Okay. Now this is actually a pretty easy thing. It's all proportional fractional stuff. So the first thing we're going to do is we're going to find out how many total minutes have been worked by our students. Okay. And so I'm going to come over here. I'm going to say, okay, 150 plus 78 plus 173 plus 204 plus 295. And what I'm going to notice is, or see, is that there are 900 total minutes worked. Okay. The next thing that I'm going to do is I'm going to go ahead and I'm going to find, well, if there's 900 total minutes worked, I'm going to find out, well, how much is each one of those minutes worth per chocolate? So I'm going to take 900. Oops, let's go here. I'm going to take that 900 and I'm going to divide it by 50 pieces of chocolate. And I do that, that tells me it is 18 minutes per piece of chocolate. So let's write that down. Say, okay, well, that is 18 minutes. 18 minutes per one chocolate, okay? And what I do know, just based off of what you see there, is we can figure out how many chocolate pieces child 1 gets, okay? Well, child 1 gets, well, we take 150, and we divide it by 18. When I find that out, I get 8.33. Let's write that in there. I get 8.33. And then I keep working all the way across the board. I want to find out everybody else's number of chocolate. Okay. And so I'm going to do that real quick. I'm going to take, okay, well, let's take 78 divided by 18. Let's take 173 divided by 18. I'm going to put a couple of these on here. 204. Divided by 18. Okay. Oh, 78 divided by 18. I'm sorry, I left that off there. Okay. And I'm just going to go ahead and write some of these on there now. So I'm going to say 78 divided by 18. Well, I know it's 4.33. 204 divided by is 11.33. 173 divided by 18 is 9.61. And I still have 295, so let's go ahead and do that. 295 divided by 18. And we have 16.38, 16.38. 3/8. So that means each kid gets these number of pieces of chocolate. Now we have a problem, and the problem is really simple. We can't take these pieces of chocolate and divide them up into fractional parts. This is actually a really complicated thing with how we deal with this process. So what we have is, one way of doing this is what we have is our upper quota or our lower quota. And sorry, my handwriting's a little messy. I need to get a stylus. I was not ready for this, okay? And what I'm gonna do is we have an upper quota, and that just means we round them all up. So 8.33 becomes 9, 4.33 becomes 5, 9.61 becomes 10, this becomes 12, and this becomes 17. Or we do a lower quota, which we round them all down. We say everybody gets 8, this gets 4, this gets 9, this gets 11, this gets 16, okay? But then we get into some issues. We may see those issues on this problem. I'm just gonna add up all the pieces. So for the upper quota, we get 9 plus 5 plus 10 plus 12 plus 17. That is 53 pieces of candy we have to hand out. That's a problem. We don't have 53 pieces of candy. And then 8, oops. Let me clear that out. Okay. We've got 8 plus 4 plus 9 plus 11 plus 16. That brings us to 48. Well, we haven't used up all of our candy, so we got to figure out who's our favorite to give that out to, right? Or we can do what many of you are thinking, well, maybe why don't we just round them all out and just give them to the, based off of the 0.5 rule. We've all seen that 0.5 rule, so let's do that real quick. If we were to do the 0.5 rule, let me go ahead and erase this. I'm going to erase the lower quota. I'll just go ahead and erase this too. Since it is a video, you can always go back. And maybe let's use the 0.5 rule. We all know the 0.5 rule. Okay, you should know the 0.5 rule. So let's see what happens there. 8.33 is below 0.5, so this is 8. This is 4.33, so that is 4. 9.61 rounds up to 10. 11.33 rounds down to 11. 16.38, that rounds down to 16. Let's just add that up real quick. 8 plus 4 plus 10 plus 11 plus 16. Oh, and we get 49. So once again, we've done 3 different rounding methods, and we end up with 3 different answers. The upper quota gave too much, the lower quota gave too little, and now we're at our normal 0.5 rule that we're used to using, rounding up or down, and we're still 1 piece of candy short. Okay, for this problem, that's not a real significant issue, but if we were doing the House of Representatives, that would create a lot of problems because the number of seats or the number of representation each state also determines the amount of power that that state gets. So let's say we were a state. We had to figure out where that 1 extra seat went to get that 1 extra piece of chocolate. Well, that makes a huge difference in the outcome of many, many situations. And hey, how you doing?